Hi guys, welcome to the energy tutorial. Energy is defined as the ability to cause changes in matter. So anytime matter is undergoing some kind of change, you know that energy has to be involved. And if you look at the pictures, you can see that on the top left, you've got an ice cube that's melting. That involves heat energy. You've got some wood being chopped, right? That involves the energy that you yourself put into your axe. And this woman is moving those weights also with energy from her body. In order to understand energy, we're going to break it into two categories. The first one is over here on the left-hand side where my arrow is pointing. This is kinetic energy. Kinetic energy is the energy of motion. If something is moving, we say that it has kinetic energy. There's also this other kind over here called potential energy, and that's energy that is stored up. But stay with me over here on the kinetic side for a minute. I've listed 5 different types of kinetic energy. You need to memorize them and you need to know for each one what is moving when we say we have that type of energy. So mechanical energy refers to just moving objects. This is what we normally think about when we think of energy. You know, something's rolling downhill, or you threw a baseball, or you yourself are running. All of those are forms of mechanical energy. Heat, on the other hand, is another type of energy. Surprisingly, it's also something moving. The something, though, is too small to see with the naked eye. It's a molecule. Molecules move all the time, which is why if you have molecules, you have heat. The reason space is so cold is because there are so few molecules in it. And molecules, no matter where they go, take this heat energy with them. The colder it is, the slower the molecules are moving, and the hotter it is, the faster they're moving. We'll talk way more about that a little later in the year. Sound is another form of kinetic energy. It's also moving molecules, but they're moving in a particular way that makes it possible for you to hear them. So when molecules vibrate in just the right way, you can detect those vibrations through the air with your eardrum. Electricity is also a form of kinetic energy. Electrons moving in a straight line, usually through a wire, creates an electric current, and that's a form of energy. And then there's light. Light also you may not realize that something is moving. We do talk about the speed of light, so you probably realize that, oh yeah, light does move, but you can't see it move because you can't see the particles that make light up. We call those particles photons, which is where the word photosynthesis comes from, or photograph, both of those having something to do with light. Okay, switch sides with me. Let's do potential energy. So if something isn't moving yet, but it has the potential to move, we say that the energy is stored up. How do we store energy? Well, you need to memorize these 5 different ways that energy can be stored. You can do it with gravity. If you take something above the earth, just hold any object above the earth with your hand, you know that you're giving it the potential to move if you release it. That gravitational field will make it accelerate towards the ground as soon as you remove your hand. The higher up you go, the more energy you're going to get out of that fall. Chemical energy is energy that is stored between atoms. It's held there by the electromagnetic force. It's very similar to gravitational energy, right? Gravity has this force field that wants to pull things down towards the earth. Well, electromagnetism has this force field that holds atoms together. And if you break that force field, just like if you release something and it heads towards the ground, you're going to get energy out from that chemical. Nuclear energy is similar. It's held together by the strong force. The protons in the nucleus of the atom want to repel each other. The strong force holds them against that. If you break the strong force, you'll be releasing those protons and they'll get pushed apart at high speed, creating a nuclear explosion. Elastic energy comes from stretching something. So picture a rubber band or a spring. Anytime you either compress something or stretch something, you're storing up energy, and that energy can be released if the spring is released or if the rubber band is released. And then there's good old magnetic energy. If I separate 2 magnets, I can feel the magnetic attraction that they have for each other, or repulsion, and that creates a magnetic potential energy. Okay, now let's practice types of energy. So over on the left-hand side, what type of kinetic energy do you want to get when you use a light bulb? Go look through the previous slide, pause this one if you want to, and go look back and see if you can figure out what type of energy do you want from your light bulb. Then come back and see if you're right. Okay, so when you use a light bulb, what you're looking for is light energy, not surprising. So now the next question is, if after we get our light energy, do we get any other forms of energy? Look over to the right. What types of energy is being dissipated or lost from the system? So a light bulb does produce light. Does it produce any other forms of energy that you can think of? Hopefully you realize that most light bulbs, the older kind, also release heat energy. So a regular incandescent bulb will actually get quite hot. We don't want to heat the room with our light bulb, so we consider that heat energy to be wasted energy. You see, whenever you use energy, usually more than one type is being created. And as a result, it can often seem to humans like we're losing energy all the time. But just like forces don't run out, energy doesn't run out either. In fact, there's a law called the law of conservation of energy that says it's not possible for energy to run out. It can just change forms and move from one location to another. Let's try this again. So let's say we have over here on the left-hand side radio speakers. What type of energy are you looking to get out of your radio speakers? Go back and look if you need to. Okay, so we want sound. We want to make molecules vibrate. But is that the only type of energy that we get out of our radio speakers? What do you think? You might think, yeah, pretty much. Except if you've ever noticed, if you go near a speaker and put your hand against it, you can actually feel the air moving in and out of it. And you can actually, if you put something light enough on top of the speaker, it'll move that stuff around. So you often get mechanical energy along with your sound energy. What about a roller coaster? Over here on the left again. What type of energy, what type of kinetic energy are we trying to get out of a roller coaster? Go back and look if you have to. So what we want from a roller coaster is to make that cart roll down the hill. That would be a moving object, so that would be mechanical. Is that all we get? Go look back at the different forms of energy and see if you can figure out what other forms of energy you might also get along with the roller coaster car rolling down the hill. I can think of a couple. One of them is some sound. You can hear that cart rolling over the top of the track. And if you felt the track, you would feel after the roller coaster passes some heat. And if it's not too well designed, you might even see a spark and get some light, which can happen when friction really builds up. Sometimes you can actually produce sparks. So that's a little bit of energy type practice. Okay, so here's another task for you. How could you demonstrate that magnets can store energy? If I gave you two magnets, what would you do in order to show that? Well, how about something like this? If you separate two magnets with your finger, you can feel that the opposite poles of the magnet are attracted to each other. And if you released by moving your finger from between the two, they would slide together, converting that potential energy into mechanical kinetic energy. What about this one? Can you find a way to demonstrate that a rubber band can store energy? This would be elastic energy, right? So the rubber band wants to return to its original shape, and when released, the elastic potential energy will be converted to mechanical kinetic energy. Here's another form of potential energy to consider. This is potential electrical energy stored in a battery. The way this works is that inside of the battery we have one chemical that has a positive charge on the left-hand side and one chemical that has a negative charge trapped on the right-hand side. Between the two, there's an insulating material that doesn't let the electrons flow back to the positive charge, which is where they'd like to go. We could convert this from a potential electrical situation to a current situation. We can make the current flow by just attaching a wire between here and here. If we do that, now the electrons will flow towards the positive charge. They won't be able to go through the insulating barrier right here, but they will be able to move along that wire because wires are conductors and they'll allow the electrons to flow right through it. So that's your little intro to energy. You should make sure that you memorize the different forms of potential and kinetic energy. You should know the definition of energy in general, and you should know the definitions for potential and kinetic energy as well. See you in class.